Assalamualaikum warahmatullahi wabarakatuh. My name is Saad Muzaffar Shah and I will be the presenter for today. Our topic for today is self-healing concrete. The group members are Adham, Mohamad, Jamal, Mohammed, Rashad, Moqbel, Mahmood, Hussun, Mahmood, Jawaheer, me, Saad Muzaffar Shah, and Mohammed, Taher, Mohammed, Salem. Firstly, we have to know what is concrete. Concrete is still one of the most widely used building materials, from foundation to structures such as bridges, dams, retaining walls, and underground parking lots. When exposed to strain, traditional concrete has a flaw. It cracks. Many elements influence the durability and strength of concrete, with crack formation being one of the most typical stumbling blocks. The structure requires frequent maintenance to decrease the chances of fracture formation, which can be costly and may further increase the structure's maintenance costs. Concrete self-healing mechanism is one technique to lower such expenditures while also increasing the structure's durability. What is self-healing concrete? Self-healing concrete in the construction industry is a fantastic invention. Its application can prevent deterioration well before the end of their useful lives. Self-healing concrete is a type of concrete that contains healing bacteria that creates limestone biologically to heal fractures that form on the surface of concrete structures. Why the need for self-healing concrete? Firstly, it is to ensure that the cracked mortar does not slip away. It is sometimes necessary to embed metal pins into the existing structure. Secondly, any concrete repair or maintenance takes longer and is sometimes difficult to obtain access to the building to conduct repairs, especially if it's underground or at a considerable height. Now, how does self-healing concrete works? When water seeps through a self-healing concrete element that has been damaged or cracked, bacteria spores are activated by the water and nutrients. These bacteria become active and begin to feed on the calcium lactate found in the concrete. As the limestone comes into touch with the atmosphere, it solidifies, effectively closing it. Because this bacterial activity has depleted all oxygen, steel reinforced concrete structures are more durable. From the figure, you can see that water enters from the left through a minuscule fissure, causing the bacterial spores to activate. With the creation of limestone, the active bacteria close the fissures, protecting the implanted steel reinforced from attack and erosion. Finding the right bacteria for self-healing concrete. Finding the correct bacteria capable of surviving in an extremely alkaline environment is vital for manufacturing self-healing concrete. As we all know, mixing water and cement produces a pH of up to 13, which is normally a hostile condition for life. At a pH of more above 10, the majority of bacteria will perish. We need bacteria that thrive in alkaline conditions, which can be found in natural conditions such as carbonate-rich soils in desert areas of Spain, soda lakes in Egypt, and alkali lakes in Russia, to build concrete that can self-crack and mend. Method of using self-healing bacteria. Microbial-induced calcium carbonate precipitation, or MICCP, or biomineralization is a process of employing microbes in bacterial concrete. Biomineralization is a biological precipitation in which organisms provide chemical precipitation of mineral phases extracellularly to generate a local microenvironment. Some usually occurring metabolic processes including sulfate reduction, photosynthesis, and urea hydrolysis end up in giving CaCO3 as their products. Calcium carbonate can be precipitated by a variety of bacteria in both natural and laboratory settings. The following factors have a major role in calcium carbonate precipitation. Firstly is the pH value. Second, calcium concentration. Thirdly, DIC or dissolved inorganic carbon concentration. And lastly is nucleation sites. The three main self-filling types are firstly vascular, secondly is mixing with other ingredients, and lastly is encapsulation. The advantages of self-filling concretes are significantly higher compressive and flexural strengths when compared to ordinary concrete. Concrete permeability is reduced. Bacillus bacteria are not harmful to humans, as they can be employed safely. The expense of maintaining this concrete is inexpensive. Self-filling concrete can restore itself without the need for additional treatment. It is highly resistant to freeze-thaw assaults, and steel corrosion is reduced as a result of crack self-repair, which is the main cause of corrosion. The disadvantages of self-filling concrete are the self-filling ingredient is held in clay pellets that make up 20% of the concrete volume. The concrete may develop a shear zone or fault zone as a result of this. There is no IS code or other code available for the design of bacteria-infested concrete. Calcite precipitate research is very expensive. The cost of self-filling concrete is nearly double that of regular concrete. And lastly, different environment factors can affect the growth of bacteria. Now it has come to an end of this presentation. To conclude, self-filling concrete is a type of smart concrete that is attracting attention in the material and civil engineering fields. Over the next few years, self-filling concrete is projected to give the biggest worldwide benefit. Bioconcrete will undoubtedly be the material of choice for contractors in the near future, as methods to improve to self-filling efficiency and lower prices are implemented. That's all from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.